So in this last section, we're going to look at a few examples where we do multi-step synthesis. So let's say we start with cyclopentanol. And at the end of the day, we want to make an ether with an ethyl group here. So an asymmetric ether, if you will, because we have a cyclopentane group on one side and an ethyl group on the other side. So we can't just, hook two of these together as was shown in one reaction. Well, how can we accomplish this reaction? Well, we could use the Williamson ether synthesis, but then we need the alkoxide in order to do that. So in order to get the alkoxide, we need NaH, or sodium hydride or sodium amide, in order to make this reaction occur. And when we do that, what we end up with is the O- and the Na+. We now need to add an ethyl group. Remember that we would add the alkoxide to the iodide. All right, the alkyl halide, in this case the alkyl iodide is what I'm using as my example, and we could complete this reaction in that way. Let's look at another one. Let's say that we have this molecule, okay, and at the end of the day, we want an OH and a CH2, CH, double bond CH2. So in this case, we've gone from the deprotonated alcohol to a phenol with an alkyl group attached to it. And I need to move my paper up here so we can do this reaction. So in order to get this to work, what we need to do is somehow add an alkyl group to this other carbon. And if you remember, this is set up for a Claisen rearrangement. But before we can do the Claisen rearrangement, we need to make the ether. To do that, we would need to add to this group. Specifically, we would use ICH2, CH, double bond, CH2. And what we would end up with is an oxygen with a CH2, C, double bond, CH2. We now have a allyl phenyl ether. This can undergo a Claisen rearrangement. If you remember, the double bond here went here, this double bond flipped over, this bond broke, and with the Claisen rearrangement, which is performed with heat, all right, we said 250 degrees C, we can ultimately form this product, which didn't look like we had a good way to do this, but this is how we can make this happen. Let's look at a last example. Let's say we start with C double bond C, H2, H2, and at the end of the day, what we want is CH2, OH, bonded to here, H, CH, and I'm giving a hint here by drawing it this way, CH2, CH2. So we've basically turned an alkene into a larger alcohol. If you remember, we could make larger alcohols with epoxides. So we need to turn this into an epoxide. One way to do that is to add oxygen, silver oxide, or silver 1 oxide, and heat. Okay. And what we end up with is the epoxide, like so. Now, how do we make carbon-carbon bonds from epoxides? To make carbon-carbon bonds from epoxides, what we need to do is we need to add a nucleophile that contains carbons. And in this case, that will be Grignard reagent. So in this case, one, we want to add ethyl magnesium bromide. So CH3, CH2, MgBr in ether. Okay, why ethyl? because we're adding an ethyl group here to this carbon. And then this bond breaks and we get the O minus. And in order to get the O minus to be an OH, the second step is to add our H3O plus. So these are just 3 examples of multi-step syntheses that could be completed with reactions learned in this chapter. It's also a good opportunity to review some of the reactions that we learned previously.